Hello students, in the last video we explained SN1 mechanism and we saw why it is unimolecular. SN1 means unimolecular nucleophilic substitution reaction, and why it is unimolecular also we have explained. In this video we see SN2 mechanism is bimolecular nucleophilic substitution reaction and its mechanism. Here I took a primary alkyl halide. Primary alkyl halide is the carbon having a halogen must be attached to only one alkyl group, the remaining two are hydrogens. Reacts with aqueous KOH and forms a product like this. This is your substrate. It generates OH minus, KOH generates OH minus, that is your attacking reagent. This is your product. This is the mechanism. Here I took a primary alkyl halide. Okay. So in primary alkyl halide, there is only one alkyl group. So this alkyl group is electron releasing nature, but it is not sufficient enough to cleave this bond. Halogen is more electron negative than carbon. It tries to pull the electron from the carbon. It tries to take the bond pair of electrons from the carbon, but it will not be completely cleaved as in SN1 mechanism, because in SN1 we have used a tertiary alkyl halide. The tertiary alkyl halide means three alkyl groups will be there. All the three alkyl groups releases electron. Therefore, this bond is cleaved easily. But here this bond will not be cleaved easily, but it develops a partial negative charge over here and a partial positive charge over here. Partial positive charge on the carbon. A nucleophile having a negative charge. So the nucleophile OH minus attacks the carbon, but the OH minus cannot attack the carbon or carbon through this direction, because this also having a negative charge. The OH minus nucleophile also having a negative charge, so there will be some repulsion between them. Therefore, the OH minus nucleophile prefers a backside attack. So it prefers to attack the carbon to the backside. Now what happens is it forms a state like this. So because of this backside attack, all the electron pairs already present, all the electron bond pair electrons undergoes repulsion with this incoming nucleophile electron pair, and we'll get this kind of state, X and OH. So this is called a transition state. It is highly unstable. A transition state is highly unstable because it looks like carbon having 5 valencies. Okay, there in SN1 we got intermediate. The intermediate, and here we got transition state. What is the difference between the intermediate and transition state? Both are unstable species, but transition state is here highly unstable than intermediate. So from transition state to the product, we are not considering as a separate step. This is a single step process, because this transition state is highly unstable. At the moment it formed, immediately decomposed to give the product. So this transition state gives a product like this. So now what happens is halogen completely cleaves away and forms a stable bond with this nucleophile. So while doing so, what happens? This much of space is empty now. Now all these bonds relax from the steric hindrance. All these bonds relax themselves, and finally they get a spatial orientation like this. And this is your product. Look at the product configuration, relate with the reactant. Reactant configuration, the bond representation of the reactant is like this, but the product configuration is like this. Therefore, this is your inversion configuration. Okay, the whole reaction is considered as a single step process. Okay, this is your single step process, is not a multi-step. SN2 is a single step process. Now we will see why it is bimolecular. That is very important aspect in this. Why it is bimolecular? As a result, in nucleophile, the halogen is substituted by OH, but why it is bimolecular? As I told, this is a single step process. Okay, So in the in this reaction, there are both alkyl halide and nucleophile is involved, right? So let us consider it is a slow step. We're not considering it as the two-step process, but this is a slow process and this is your fast. Okay. So in this slow process, so step, how many reactant molecules are involved? Both the alkyl halide and the substrate is involved. Rate is proportional to both alkyl halide and nucleophile. One alkyl halide and nucleophile is involved. Therefore, the molecularity is 2. Therefore, it is SN2 reaction. Thank you.